Once you learned what arithmetic and geometric sequences are and how to model them and create their equations, now we're looking at adding or summing up arithmetic sequences and geometric sequences, and that's from Unit 7, Lesson 2, Investigation 2. So here we have an arithmetic sequence, and they give you the recursive formula. Let's make sure we can interpret what that means. This says a sub 0 is 4. Well, if I was making a table, my 0 term would be 4. My 1 term would be, well, if this equation says it's my now or my next equals now plus 7. So we're adding 7 every time. So 7 plus 4 would be 11. My second term would be 18, and so on. Now, by the power of technology, I've filled out my table here, and I went out to my 10th/11th term. While we're at it here, remember they said a sub 0 is 4. So that means my first term that they give me is 4. When someone says find the sum of the first 10 terms, and we're given this to start, we're counting that as our first term. The first term is the 4. So you've got to be careful because that was a sub 0, and it's the first term. So when they want the sum of the first 10 terms, they actually want, let's count how many terms. There's our first term, even though I plugged in 0, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the 10 when I plug it into an equation, but it gives me 74. It's not my 10th term because I'm starting at 0. That starting value is important. If they would have told you a sub 1 is 4, then your 10th term would have been under the 10. Now, we'll show you how that I'll show you how that matters here in just a second. So, if I weren't able to write out all these 10 terms, this didn't take me too long, but if this would say the first 40 terms and we don't have time for that, it's important to have formulas that we can use to make this a little quicker. But again, I like to check if I can. So, and we do want to use formulas, so I'm going to show you that here too. It is important to try to find a function formula. Now, we've made these before, so since this is growing at a steady rate of 7, my function formula is going to be 7n. Now remember, on the table it has to work. If I plug in 0, I need to get 4. So that is my 0th term. That'll be part of my equation. Let's plug in 3. 3 times 7 is 21, plus 4 is 25. So it works. If I want to get whatever term, I can plug in that number. Now be careful, because when they say the first 10 terms, since I started at 0, I actually want to plug in 9 to this equation. Let's try it. 7 times 9 gives me 63, and then I add 4. That'd give me 67. There's that term I want. So if they say find the sum of the first 10 terms, you're actually going to plug in 9 since we started at 0. There's that starting value concern. Now to sum them up, if I wanted to, I really could just add those. So I'd say 4 plus 11 plus 18 plus, I'm going to pretend this was more than 10 and that I didn't actually write these all out. My last term here is the 67. Well, how would you know what that term is? That's why it's important to create the function formula up here and make sure that it works for the ones you do know. So I would actually plug in 9, because that'd be the 10th term, into my function formula. Even though they said I didn't have to create it, it's helpful to do so. And then I get 67. To find the sum of these, I actually did find the sum by hand because I have them all written out. And I know my goal here for the first 10 terms is 355. It's okay if you want to check. Whoops, sorry. It's okay if you want to check if you can write them all out. If you got time for it, go ahead. Let's show you how this Gauss guy finds the sum of the first whatever terms. He starts the formula by his initial value and maybe does the next term, but then leaves it on and goes until the last term by either plugging in, for this case, the 9 into his function, or if you started at 1, you'd plug in 10. Then he reverses the sequence and goes 67 plus, I can subtract 7 from that pretty easy, plus, and you go all the way around, you got plus 11 plus 4. Now, we're going to add these together and something kind of crazy happens. 67 plus 4, 71. 60 plus 11, 71. Weird. All of these come out to 71 when you reverse the sequence and add them together. Well, how many 71s will I have? I'm finding the sum of the first 10 terms, so I'm going to have 71 times 10 of them, which is 710. Now remember, this was 71 because we double stacked the sequence. So I actually don't want twice the sequence. I'm going to divide by 2, and that gives me 355. Now I know that answer is good because it matches what I got when I actually just added all of these numbers together, but that Gauss formula is important. You will take, in short, your initial value, okay, your starting term, plus your nth term, we'll call it. So if you want the first 30 terms, you'd plug in either 30 or 29, depending on your starting value, and multiply it by the number of terms that you wanted, and then divide it all by 2. This is kind of a shorthand form of your Gauss formula, and I know you have that on the notes, or you might have taken them in class, but his formula will work for any arithmetic sequence. Just be careful of that start value. If you start on a sub 0, and I want the 30th term, I'm actually going to plug in 29 into my function formula. Double check that function formula and make sure it works for those terms that you already do know.